One source of excitement in the scientific community is the launch and commissioning of the James Webb Space Telescope. As the most powerful and expensive telescope ever, it's understandable that expectations are so high. However, can the JWST live up to these expectations? Scientists got an early answer to that question with the terrifying discovery the Space Observatory has made on Jupiter. What has the most powerful telescope in human history found on Jupiter? Has it finally spotted aliens on this massive planet? Should you be concerned about this discovery? Make sure you watch this video to the end as we bring you James Webb Space Telescope's terrifying new discovery on Jupiter that changes everything. When the James Webb Space Telescope launched in December 2021, it was a real once-in-a-lifetime achievement for everybody involved. For many of the staff, that may be the finest moment of their careers, as another iconic telescope might not launch before they retire. However, celebrations were muted as the launch rocket sped to space because the real test was just beginning. Designing, developing, and launching the telescope was one thing, but ensuring it reached its intended orbit in one piece and worked perfectly was another. That was because of the nature of the JWST. It is one of the most complex objects ever launched to space. Because of its size, the JWST needed complex mechanisms to fold some parts that would have proven too big for the launch vehicle. These parts, including the most crucial components like the primary mirror and the massive heat shield, had to unfurl on their own as the observatory sped to its final destination. The real reason scientists were apprehensive was that they would get no opportunity to rectify anything that goes wrong or gets broken. The JWST is located in orbit around the Sun about 1 million miles from the Earth, making it practically impossible for astronauts to visit it to carry out any repair or upgrade, so it was a huge gamble on a telescope costing almost $10 billion. The JWST's mission has several broad objectives, and the components are designed to enable it to carry out these objectives. The observatory is designed to observe farther into the universe than ever before, search for the first stars and galaxies created after the Big Bang, better understand how planets, stars, and galaxies are born and evolve, explore distant worlds and study our solar system, and determine the potential for life on planets around other stars. This means the JWST can peer far into the universe. In fact, it will bring us the closest to the Big Bang as we have ever been. However, this does not mean the JWST cannot see objects relatively closer to us. During the testing period, the telescope was trained on the planet Jupiter by NASA's scientists, and the discoveries were nothing short of stunning. Jupiter is far from the Earth, but the actual distance constantly varies because both planets follow elliptical orbits around the Sun. However, when the two worlds are closest to each other, they are separated by 365 million miles or 588 million kilometers. When at this position, the planet shines even brighter than Venus from our perspective on the Earth. At its farthest location, Jupiter lies 601 million miles or almost 1 trillion kilometers away. Jupiter is so far away from the Sun that it takes 11.86 Earth years to complete just one orbit. As Earth travels around the Sun, it catches up with Jupiter once every 398.9 days, causing the gas giant to appear to travel backward in the night sky. Jupiter is special in our solar system because it is the largest planet. It has a mean radius of 43,440.7 miles, or 69,911 kilometers, which is about a tenth that of the Sun. However, its rapid rotation of one spin in 9.8 hours causes it to bulge at the equator, where it has a diameter of 88,846 miles, or 142,984 kilometers. In contrast, the diameter at the poles is more than 5,000 miles shorter. This stretched shape is known as an oblate spheroid. If you walk around Jupiter at its equator, it will take you 272,946 miles, or 439,264 kilometers, which is more than 10 times the distance around the Earth. Jupiter is made of gas, and this is why its surface is considered uniform. As such, it lacks high and low points, that is, mountains and valleys such as those found on rocky terrestrial planets. In fact, Jupiter's structure is similar to the Sun, and if it had 75 times more than its mass, it would have undergone hydrogen fusion and acted like a star. Jupiter is so large that the masses of planets found outside the solar system, known as exoplanets, are expressed in terms of Jupiter's mass. The JWST has about 2 decades to function before running out of fuel. During this period, it will concentrate on its main tasks already mentioned. However, scientists will be able to use it to pursue other goals, and this involves Jupiter. This will be no mean feat because of Jupiter's brightness and the extra sensitivity of JWST's instruments. Apart from that, astronomers must also consider the planet's rotation. Because Jupiter completes one day in only 10 hours, several images must be stitched together in a mosaic to capture a certain area fully, a task made more complicated when the object itself is moving. Many telescopes have studied Jupiter and its storms, but the JWST's large mirror and powerful instruments will provide new insights into the massive planet. The JWST will study the atmosphere of the polar region, where NASA's Juno spacecraft discovered clusters of cyclones. Spectroscopic data from JWST will provide much more detail than has been possible in past observations. It will help track the planet's winds, cloud particles, gas composition, and temperature. Future solar system observations of the giant planets with the JWST will benefit from the lessons learned in these early observations of the Jovian system. The team is tasked with developing methods for working with the JWST's observations of solar system planets, which can be used later by other scientists. Like the other gas planets in the solar system, Jupiter has rings. The ring system contains 3 parts: a flat main ring, a halo inside the main ring shaped like a double convex lens, and the Gossamer ring exterior to the main ring. Jupiter's ring system is exceptionally faint because the particles that make up the rings are so small and sparse that they do not reflect much light. Next to the brightness of the planet, they practically disappeared, and this presented a challenge for astronomers that wanted to study them. However, with the JWST, the rings have no hiding place, as you shall soon see. Jupiter has so many moons that it can gift some of them to other planets. The JWST will study some of them, including the ones with the most fascinating features from a scientific point of view. For instance, astronomers will finally be able to explore icy Ganymede, which is the largest moon in the solar system. It is larger than Mercury and has its own magnetic field, the only moon with such a distinction. JWST will help to understand the outer parts of Ganymede's atmosphere, its exosphere, to throw more light on the moon's interaction with particles in Jupiter's magnetic field. Ganymede has been suspected of harboring a liquid saltwater ocean under its thick ice surface. The JWST will confirm this with a detailed spectroscopic study of surface salts and other compounds. The team's experience while studying Ganymede's surface will be helpful in the future research of other icy solar system moons suspected of having subsurface oceans, including Saturn's moon Enceladus and fellow Jovian satellite Europa. Another interesting Jupiter moon that the JWST will study is Io, which, in contrast to the icy Ganymede, is the most volcanically active world in the solar system. This moon has hundreds of volcanoes that make Earth's volcanoes appear like child's play. It also has lakes of molten lava and smooth floodplains of solidified lava. What the JWST will do is help astronomers learn more about the effects of Io's volcanoes on its atmosphere. Of particular interest are the stealth volcanoes, which emit plumes of gas without the light-reflecting dust that can be detected by spacecraft like NASA's Voyager and Galileo missions, and so have thus far gone undetected. JWST's high spatial resolution will be able to isolate individual volcanoes that previously would have appeared as one giant hotspot, allowing astronomers to gather detailed data on Io's geology. The JWST has more than proven it's up to the task with the first set of pictures of Jupiter that it has returned. While testing and setting up the telescope, NASA engineers took a few shots of the Jovian planet using the NIRCam instrument, and even though the images did not get the usual finishing that final images get, they are still stunning as to the amount of details we can see. They also exceeded the expectations of the mission scientists. The images include the planet itself, some of the moons, and data from some asteroids. On the planet, the JWST captured the distinct cloud bands around the giant planet, as well as the Great Red Spot, Jupiter's famous gigantic storm. The whitish coloration you observe in the picture is because of the way JWST's infrared image was processed. You can clearly see Europa on the left. It is the dark spot with bright edges. It is interesting that in the infrared, Europa is bright enough to create diffraction spikes. The diffraction spikes come from the hexagonal shape of the mirror segments as they diffract the light from bright objects like stars, or in this case, a nearby moon. But if you can look closely, you will see Europa's shadow on Jupiter to the left of the Great Red Spot. Other visible moons include Thebe and Metis, which appear as small white spots. You can also spot Jupiter's thin rings in some of the new images using JWST's NIRCam long-wavelength filter image. Nobody knew Jupiter had rings until one of the Voyager spacecraft discovered it in 1979. The Jupiter teams are still learning to interpret data from the JWST, but they are excited already by how much they can learn by spending more time on the telescope. JWST also obtained these images of Jupiter and Europa moving across the telescope's field of view in 3 separate observations. This test demonstrated the ability of the observatory to find and track guide stars in the vicinity of bright Jupiter. The scientists using the JWST are interested in how fast an object could be moving, and the telescope will still track it. This is important in the study of moving objects in space, so during the commissioning, the team used the JWST to track an asteroid called 6481 Tenzing, and it is located in the asteroid belt between Mars and Jupiter. The JWST was designed to track objects moving as fast as Mars with a maximum speed of 30 milliarc seconds per second. However, during commissioning, it became clear that the Space Observatory could do more. The team conducted observations of various asteroids and proved they could get valuable data with all of the science instruments for objects moving up to 67 milliarc seconds per second, which is more than twice the expected baseline. They said it was like photographing a turtle crawling when you're standing a mile away. Many people have younger and smaller siblings that they will protect jealously. However, that is not the case with Jupiter. Instead of being a protective big brother to the Earth, the jumbo planet actually puts us in harm's way. Using computer simulation, scientists have found the largest planet in our solar system's gravity hurls deadly asteroids towards us instead of keeping them away as previously assumed. Scary, right? A paper worked on by NASA's Jet Propulsion Laboratory suggested evidence shows Jupiter was not a protector planet, using its own gravity to suck asteroids away from Earth's path. Jupiter's gravity may actually nudge some asteroids toward the Sun, where they stand a chance of colliding with our planet home. For many years, our understanding of the relationship between the Earth and Jupiter has been shaped by the Jupiter shield theory, which says the bigger planet acts like a giant space shield due to its huge mass, which causes it to suck in or deflect dangerous debris. But now, thanks to the work of Kevin Grazier, the shield theory is slowly falling out of favor. He published several papers explaining why he thinks Jupiter is a sniper rather than a shield. Actually, the relationship is complicated because Jupiter sometimes protects the Earth by deflecting comets away from the Earth. But new evidence proves that it's just as likely to take objects that come nowhere from the Earth and flings them in our direction. Of course, comet and asteroid strikes on the Earth are no jokes. You can ask the poor dinosaurs that went extinct. However, space is full of these dangerous objects, and the Earth needs protection, so it's important to establish whether Jupiter is a friend or foe. Interestingly, it took strikes by comets and asteroids on the Earth when it was young before all the ingredients needed for life were assembled, but they could as well wipe out the life they have created in a few seconds. Overall, Jupiter is our friend because it slings most of the comets coming from outside the solar system back out. There are even signs that it has taken hits on our behalf. The search for signs of life on other planets continues. Jupiter has been one of the targets of such research. Have scientists discovered anything noteworthy on Jupiter? Data from NASA's Juno probe indicates that about 0.25% of the molecules in the atmosphere over Jupiter's equator is composed of water. Let us save you the mathematical calculation and expression of that 0.25%. That 0.25% is based on a prevalence of water's components, hydrogen and oxygen, 3 times more than at the Sun. Amazing! Why this data is amazing and shocking was that NASA's Galileo data about Jupiter was different. After this latest discovery, scientists checked Galileo's result and compared, and they discovered something. What did they discover? They discovered that the result of Galileo's was drier than that of Juno. Galileo's results sent back data showing 10 times less water than scientists predicted, and more weirdly, the amount of water appeared to increase the deeper the spacecraft went into Jupiter's atmosphere. It happened that at the same time Galileo was plunging into Jupiter, there was a ground-based infrared telescope that was able to measure water concentrations at Jupiter. This telescope showed that Galileo may have accidentally hit a dry spot during its probe. This could mean only one thing: water is not well mixed deep in Jupiter's atmosphere. This is also proven by Juno during its first 8 flybys. It revealed that there is a lack of atmospheric mixing on the planet and its surrounding systems. Juno principal investigator at the Southwest Research Institute, Scott Bolton, said in a statement, "Just when we think we have things figured out, Jupiter reminds us how much we still have to learn." He added, "Juno's surprise discovery that the atmosphere was not well mixed, even well below the cloud tops, is a puzzle that we are still trying to figure out. No one would have guessed that water might be so variable across the planet." Working with the results of Galileo's probe and that of Juno, scientists will be able to get more details about Jupiter, the Jovian system, and the solar system. Jupiter is known to probably be the first planet to form. This indicates that Jupiter could have sucked up most of the gas and dust that the Sun's formation left behind. Then the question, how much water did Jupiter suck? Did its moons take part in the evaporation of water? Answers to these questions would lead scientists to identify the most plausible theories to explain its formation. The next discovery on Jupiter involved an event that scientists assumed was a comet strike on the planet, but turned out not to be so. What then exactly happened? From the Earth, astronomers noticed a flash that lasted only 2 seconds and was gone. They immediately suspected that the giant planet had been hit by something, although they didn't know how big the object was or how deep the atmosphere was penetrated. The next step was to begin searching for a black eye pattern left by former impactors, but they eventually turned to the Hubble telescope for help. But not even the telescope could sight anything, as there was no sign of debris. The implication after 3 days was that the object that struck the planet did not descend beneath the clouds and explode as a fireball. If that had been the case, the dark sooty debris would definitely have been ejected to rain down onto the clouds, so it was assumed the flash came from a giant meteor burning high above Jupiter's cloud tops. Imagine for a second that intelligent aliens live on Jupiter. They will communicate with one another on the planet and may even try to communicate with their kind not on the planet. Did NASA eavesdrop on one of their communications in an audio clip it recorded on planet Jupiter? The audio clip was gotten from Juno's Ganymede flyby. It was generated from data captured on June 7, 2021, during the spacecraft's closest pass yet to Ganymede. The sound was similar to that of a robot or a dial-up modem. This discovery joined the list of fascinating discoveries of Jupiter alongside the presence of water molecules. The audio was captured by Juno's WAVES instrument, which was designed to measure radio and plasma waves detected in Jupiter's magnetosphere, the bubble of charged particles that envelop the planet. Commenting on the audio, Scott Bolton said, "The soundtrack is just wild enough to make you feel as if you were riding along as Juno sails past Ganymede for the first time in more than 2 decades." Scientists are still studying the wave data collected during the Juno flyby and attempting to decode what frequency changes are present within the recording mean. One of the many moons of Jupiter is Io. This moon is fascinating to scientists because despite being icy, it has amazing dunes. The question researchers are trying to answer is how Io got its dunes. Current scientific understanding dictates that dunes by their nature are hills or ridges of sand piled up by the wind. And scientists in previous studies of Io, while describing its surface as containing some dune-like features, concluded the ridges could not be dunes since the forces from winds on Io are weak due to the moon's low-density atmosphere. The clue to the answer lies in data that are getting old already. During the Galileo's mission from 1989 to 2003, scientists were able to gather data so numerous that up to this day, nearly 20 years after, scientists are still poring over all the data. It was from this pile that the insights needed to understand what is happening on Io came from, and it had to do with volcanic activities so strong that they are reshaping the surface of the satellite and creating the large-scale features that resemble dunes. So Io's surface contains a mix of black solidified lava flows and sand, flowing effusive lava streams, and snows of sulfur dioxide. The group of researchers actually used mathematical equations to simulate the forces on a single grain of basalt or frost and calculate its path. When lava flows into sulfur dioxide beneath the moon's surface, its venting is dense and fast-moving enough to move grains on Io and possibly enable the formation of large-scale features like dunes. After devising or duplicating the mechanism by which the dunes could form, the researchers checked the photos of Io's surface taken by the Galileo spacecraft for corroboration. The spacing of the crests and the height-to-width ratios they observed were consistent with trends for dunes seen on Earth and other planets. Now, Jupiter is a massive planet. Any massive object affects other objects near it. So what effect does Jupiter have on the rest of the planets in the solar system? Thanks to its massive gravity, Jupiter has been fingered for pushing planets Neptune and Uranus away from the Sun. This is due to a theory known as the NICE model, which claims that Jupiter and other gas giants caused a phenomenon known as the Late Heavy Bombardment, a time when the Earth and other planets nearby were bombarded with debris. However, that was in the past, as Jupiter now plays a mostly protective role to our planet. Jupiter helps to keep asteroids and comets from bombarding Earth, protecting the inner planets by acting as the vacuum cleaner of the solar system. The enormous gravity it generates can suck in and absorb smaller objects, like the 1994 collision of Jupiter and comet Shoemaker-Levy 9. Jupiter can also propel them out of the solar system entirely, but that same gravity can still accelerate some of those objects toward the inner planets too, so it's a mixed blessing. In all of this, you may be asking if there is a possibility of life on Jupiter. Well, according to scientists, if life were to be on Jupiter, it would have to exist at a height literally in the clouds, where the temperature is about 70 degrees Fahrenheit or 21 degrees Celsius. But studies suggest Jupiter has enough water to sustain life, so perhaps one day we will find evidence of life on Jupiter. Now, if you have heard of the Great Red Spot on Jupiter, are you aware that there is a Great Blue Spot on the planet as well? What is the Great Blue Spot all about? It is magnetic. A team of NASA researchers, including Jack Conanay, came up with the most detailed map of the planet's magnetic field, and it revealed something spectacular. The map is compiled from data obtained from 32 orbits during Juno's Prime mission. The group of researchers claimed their new map provides new insights into Jupiter's mysterious Great Blue Spot, a magnetic anomaly at the planet's equator. Juno data indicate that a change in the gas giant's magnetic field has occurred during the spacecraft's 5 years in orbit. What is happening is that the Great Blue Spot is drifting eastward at a speed of about 2 inches or 4 centimeters per second relative to the rest of Jupiter's interior. At that rate, the Great Blue Spot will go around the planet completely in about 350 years. In contrast, the more popular Great Red Spot, the long-lived atmospheric anticyclone just south of Jupiter's equator that refused to die, is drifting westward at a relatively rapid clip, going round the planet in only about 4.5 years. Apart from this, the new map shows that Jupiter's zonal winds are pulling the Great Blue Spot apart. Zonal winds are jet streams that run east to west and west to east, which gives Jupiter its distinctive banded appearance. This means that the zonal winds measured on the surface of the planet reach deep into the planet's interior. The new magnetic field map also enables Juno scientists to make comparisons with Earth's magnetic field. The data suggests to the team that dynamo action, that is, the mechanism by which a celestial body generates a magnetic field in Jupiter's interior, occurs in metallic hydrogen beneath a layer expressing helium rain. Now, Jupiter has been confirmed to have almost 80 moons, but why does the planet have such an unusually high number of moons? In comparison, the Earth only has 1. Saturn has 82 confirmed moons, but the race between the two planets is still on as scientists keep discovering more moons. What is more, when astronomers from the University of British Columbia studied only a tiny portion of the sky, they discovered about 45 candidate moons with a diameter of more than 800 meters. By extrapolating, they concluded that Jupiter might have more than 600 moons. The reason Jupiter is such a moon magnet has a lot to do with its stupendous mass. Earth's one and only moon likely formed billions of years ago after a vast protoplanet hit the Earth. But most moons, especially around gas giants, don't have such an exciting history. Jupiter and other gargantuan planets usually capture rocky objects, including minor asteroids, to full-fledged mini-planets with volcanic activity like Io. Apart from its mass, Jupiter's location plays a part too. Because it's so far away from the Sun, Jupiter can exert a larger area of influence or control. The Sun might be mighty, but its gravitational force lessens the farther away you move from it. This is why Venus and Mercury, the two closest planets to the Sun in the solar system, have no moons at all. Earth boasts of only one, and Mars has 2 tiny satellites. Also important, although to a lesser degree, is the gas giant shape. A celestial body that is regularly round will have a more stable orbit than a potato-shaped one. Jupiter is almost perfectly round, which may have helped it capture some additional small satellites, especially in its lower orbit. The next discovery involves an incredible similarity between the Earth and Jupiter. Look at the images below. Do you see the eerie similarities between the two? One image was taken on the Earth, while the other was taken on Jupiter, yet they look frighteningly alike. So what is going on here? On the left is a phytoplankton bloom in Earth's Norwegian Sea, while on the right you are looking at turbulent clouds in Jupiter's atmosphere. Here is NASA's explanation. The simplified model of Jupiter's pole shows that geometric patterns of vortices, like those observed on Jupiter, spontaneously emerge and survive forever. This means that the basic geometrical configuration of the planet allows these intriguing structures to form. Although Jupiter's energy system is on a scale much larger than Earth's, understanding the dynamics of the Jovian atmosphere could help us understand the physical mechanisms at play on our own planet. Oceanographers have used Juno's images to study the turbulent atmosphere at Jupiter's poles, helping us understand the forces that drive the storms there.